Okay, in this video, I'm going to show the collision system that I use for the game and some of the obstacles. So here's one of the obstacles, both the geometry and the collision mesh, which I'll talk about after I show the mesh. And as you can see, the back is hollowed out just to save on the size of the mesh and also save a little bit of vertex processing in the vertex shader, since we never see much of the back. Now, this is the collision mesh. As you can see, it's something really simple, and of course it would be aligned, so it would go like this. It would be over the actual obstacle. And you may be wondering why I don't have a collision mesh for the legs, and the reason is I'm just cutting the player some slack. I just want him to go under. So if he strafes and goes across the legs, I'll let that go. So as you can see, it's just a simple brush. And I guess to define a brush, it's sort of a simple piece of geometry. And what I save out are the actual planes that make up the geometry. So it's just the normal and the distance to the plane along that plane normal. I'll show the format once I export it. And of course, the volume needs to be closed and convex for this to work. I'll show some links in the description of the video so you can read up more about convex collision brushes, but it's a bit of an old school technology. I guess the first use in a game, at least that I found, was the old Quake games back in the id Software days of the 90s. So it's a little bit of old technology, but I think for mobile games it still has a use because it has low processing power and it's simple to implement. So I'll show another couple of objects. And again, you can see a very simple collision mesh. Again, it would be aligned like so. And again, you can see the back of the model is cut. It's not visible. And the final object. This one's already aligned, but I'll move them out of the way. Wrong. Well, either way. So as you can see, there's some really simple collision for this. I also, the lights, like the little signal lights, I ignore. I'll let that fly. But when I show it in the game, you'll see that you can get some pretty sophisticated behavior just by having really simple geometry for the collision. You don't need to have anything sophisticated. So what I would do for export, if I wanted to do an export of the brush, let me cut that out. I just have the plugin, and again, I just select collision brush and select it, and I just hit export. And that would export the brush, which I would then use in collision detection. So I'll show the format. This is an ASCII. I obviously save all this in binary, but here you can see the brush is 6 planes. I have the bounding box for the brush, and then each one of the planes. The first three numbers here are the normal, and then the distance to the plane along that plane normal from the origin. So as you can see, it's pretty compact what I save. And then I use these planes to successfully test for a collision against the player character. So as you can see, it's 6 planes since it's rectangular. And of course, I also export the meshes, but those are saved as a mesh object. So here I actually traverse the polygons and save that out. And one of the reasons why I used collision brushes is it's just simpler to do the collision detection. It's more, I could say, robust, and I didn't want to burden the processor with per polygon collision detection. I really don't need that for this game. I know there's some engines that use a physics engine to resolve all the collisions, and I wanted to get away from that because I don't think this type of game needs that kind of precision. So I came up with I guess my own ideas of how things should be, and I'll show this running in the game once I finish here with the models. So the next thing I'll show is the actual models in the editor. So here I've exported everything, and as you can see, have an array of obstacles that the player needs to dodge. And of course, in the level editor, I do use the per polygon collision detection because, you know, I want you to select this easily. So if you, for instance, hit it on an angle, I need to detect the collision with the signaling light so that you can select the object. And it's very easy to place things in the editor. It's just drag and drop. You've got your little UI here, so I can dump things as I see fit. So then when I'm happy with what I've done, I look through, make sure everything's set up properly. All right, well, that's enough. And then I just hit export to export this into a format that can be run by the iPhone game. And I'll show the format. Again, in ASCII mode, I save it in binary and it's a little bit compressed, but it's a much smaller format that I then load up by the engine on the iPhone. So here's a test. And if I go up a little bit, I'll describe a few of the things. So each one of these is an object or an asset. So what these are, for instance, the little obstacles. So I'll just show what I've saved. So I have a unique identifier, the object resource. So there's 3 types. There's large obstacles, medium obstacles, and small obstacles. The position, orientation, which I actually don't save out in the binary version, and then the bounding box of that object in world space, which I then use for rough collision detection and for visual determination of which objects are visible in the scene. So if I save that out, then what I do is I store all these objects in a hierarchy. Here it is. You can see there's 127 nodes. So this is a binary tree that sort of partitions the space. And eventually at the root nodes, which are these ones right here, -1, I store the actual objects. So I would store an index into this particular object. So that's what you see here. So object 11 is stored in this root node. In this one, object 10 and 9. And that would refer to the 10th and 9th object up here. Now, you may be wondering, why are you partitioning all these objects? And it's because it's much easier to do collision determination if you don't have to do collisions. So when I save in a tree, at each step in the tree, I can potentially skip half the nodes during each traversal of the tree. So then I skip a lot of tests, and eventually I get to a root node, and then I can do potential collision detection. So, for example, if I'm over here, and the player's right here, and he's about to hit this this obstacle, I don't do tests for all the obstacles that are in the distance. I traverse the tree, and eventually I'm going to hit the root node where I might potentially collide with this obstacle. And that's why I have the space partition like this. This will scale. It doesn't matter how many objects I add to this. I'm only sort of bound by memory constraints, but I can skip a lot of collision tests by having everything in a hierarchy like that and not having to do, for instance, tests for each and every one of these objects. The tree, for instance, lets me skip everything past this area if I don't intersect that particular node. So that's why I save everything out in a hierarchy. And as you can see the back where there's no triangles, again, just to cut down a little bit on the size of the mesh and to lighten the load a bit on the vertex shader, since it doesn't have to process back faces. Or maybe it doesn't, yeah, I don't know. It may not get to do that, to process the back faces in the vertex shader, but either way, the mesh is smaller by just removing unnecessary triangles that don't contribute to the scene. This is all you see when you're playing, so it's a good optimization. So that's pretty much what I've done for the, I guess, the tool side of this video that I've done. And in the next section, I'll show it in game with the character running around and doing responses to any collisions that he encounters in the world. Thanks. Here we have the character running through that level I showed in the editor. And then I'll show him jumping around and colliding with obstacles. There you saw a collision. There's another one. So as you can see, it works in the engine. So I can jump around. Trip. The way I handle tripping is whenever I detect a collision, I do a step up to see if I can step over the collision, and if I can, I set the trip state that plays the trip animation, and then I go back to the running state, or I fall to the ground if I'm airborne. So that's how I do that in the response handler. And I guess I'll talk with how you do all these collisions is first you need something to detect the collisions. So that's just the test with the brushes, and that'll return either yes, you've collided, and here's the object you've collided with, and here's the contact point. So that's the first step of what you need to do. And then what I consider the harder step is the collision response. For instance, have him bounce around and slide off of objects, or trip on parts of the geometry. So that's what I find the trickier part, to actually analyze the data that's returned for you from the collision handler and do some sort of response that the player can understand. And here I'll do something where he splats, which is one of the states. If he see womp, and then he falls to the ground. So as you can see, the collision is actually working, and I'll just load it up again and run it some more to see some other states. Here I'll just show him moving around, doing a little trip. There, he's tripping again. And I'll show him do the splatting when he's on the ground. And again, all this is handled by the response handler that then changes the state of the player. I use a finite state machine to keep track of the player state. It's kind of an old school way of doing it, but it's simple and it works. So that's why I went with it. So when he jumps, the character player system is updating the state of the player as he's moving, and also based on what the response handler detects based on the collision system that I have. But as you can see, it scales fairly well despite all the objects that I have, and that's partly because, first of all, brushes are really simple to do collision detection with. It's just a collision plane, so the math is fairly routine. And also I have that tree that allows me to skip tons of these objects if I don't traverse down the node when I'm doing the collision detection. So at every node of the tree I could potentially have when I need to search. So now I'll just end it with him splatting. And hopefully I can get caught up with all these videos, because I've had this for quite a while and I've just now gotten around to it. So I'll start uploading more videos more consistently. And here's the splat. Again, he just falls. Again, that's the collision response handler. It detects that you've hit something and that you're on the ground, so I go into a different state than what I showed before. So that's all I have to show for now. So hopefully that gives you an idea of what I'm doing with collision detection. So till next time, thanks and bye.